All right, so it says in chapter 1, you wrote 2 to the third as 2 times 2 times 2, right? 2 to the third means 2 times itself 3 times. So then over here on the left, what would what's 3 squared mean then?
9.
I mean, what does it mean though? 3 times 3, yeah. Yeah, it is 9, but it means 3 times 3. So this means 3 times 3. And what does 3 to the 4th power mean? That means 3 times itself 4 times, right? All right. So then over here, right here, you got 3 squared times 3 to the 4th. Well, we just said that 3 squared was 3 times 3, right? And 3 to the 4th was 3 times 3 times 3 times 3. So then, what would you have all together then? 3 to the what? Yeah. Yeah, so if you look at this, you've got 3 times 3 times 3 times 3 times 3 times 3, so that would be 3 to the 6th. So then, what did you do, again, kind of ignoring what's in the middle, what did you, as a shortcut, what did you do to get from here all the way to here?
2 plus 4.
Yeah, 2 plus 4, right? So you added the exponents. So if you have the same base, there's a 3 and a 3, and you multiply them together, all you got to do is add the powers, okay? So that's what that blank says here. What did we do with the exponents? We added them. That looks terrible. Let me see if I can write that a little neater. Yep, so we added them. So then that'll give you the first exponent rule. They say that's for a product of powers. So the rule in general would look like this. So you'd have a to the m power times a to the n power, and that would be a to the what? What would it be? Come on, you got to add them. Yeah, m plus n.
I did it.
So it's m plus n. All right, so let's do these examples. So, number 1. So number 1 is going to be 3 to the what power?
7.
Yeah. Yeah, you're just going to add the powers, right? It would be to the 2 plus 5 power. So you get 3 to the 7th. And you can leave it like that, okay? 3 to the 7th, that's a pretty big number. Not one that you would know out of your head. Now, if you have your calculator, I'll just write this down. You don't have to write this down. In the calculator, you want to put it as you want to put 3, and then you want to use this key. And then 7. So if you do that, 3 to the 7th power is actually, 2,187. But now, if it was like 3 squared, you would write 9, okay? But since it's 3 to the 7th and it's 2,187, you can just leave it as 3 to the 7th. Okay, so the next one.
Thank you.
Quiet, please. I'm recording this. So number 2. Aiden, no more sneezing, all right?
Yes.
So then on number 2, you can multiply in any order you want, okay? Multiplication is commutative. So we're going to do 2 to the 4th times 2 to the negative 2 power times 3 to the 4th times 3 to the 2nd power. So we're going to get 2 to what power? Yep. You add the powers. So 4 plus negative 2 would be 2 times 3 to the Yep. 4 plus 2 is 6. Now, again, you could leave it like that. Or, what's 2 squared?
4.
That's 4. 3 to the 6th, that's not one I have memorized, so I'd have to use the calculator. So 3 to the 6th would be 729. And so then you would get 729 times 4. So your final answer would be 2,916. But again, that's only if you had the calculator for that part. For our purposes, we're trying to make sure that you guys know how to, that you know how to use the exponent rules. So I'd probably just leave it like this. All right, let's keep going. So number 3, again, we can multiply in any order. So which 2 would you want to multiply?
Q.
Yeah, the q's. So you got q to the 3rd times q to the 6th. And then times r squared. So we get q to what power? Yep, good. Yeah, you add the powers. So when you have the same base, you got a base of q and a base of q, and you're multiplying them together, then you just add the power, so that would be 9. So you get q to the 9th times r squared. Did I circle that? Yeah, I did, okay. So then this one, what's the power on that last n there?
1.
A 1. So that is a 1 right here. So again, you're just going to add the powers. So you do have like bases, right? All these are n's. So it's going to be n to the 3 plus negative 4 plus 1.
0.
That is 0. And then any number to the 0 power is? Good, 1. So the answer is 1. All right, then they got one example here about scientific notation. So you want to multiply these two numbers, but the second number is not in scientific notation. So the second number is 15,000. Right now the decimal point is right here. We need to move it so that there's only one digit to the left of the decimal point. So we would have to move it 1, 2, 3, 4 spots, put it right there. So that's going to make this problem then is going to be, it's going to be 1.86 times 10 to the 5th times, that second number is actually going to be 1.5 times 10 to the what? How many spots did I move it?
4.
4. That's 1.5 times 10 to the 4th. And again, we can multiply in any order we want. So what I would do with this one is I would, I'm going to come up here. So I would multiply the 1.86 times the 1.5. And then I would multiply the 10 to the 5th times the 10 to the 4th. So when you multiply these two, you're probably going to use a calculator. So I got 1.86. Oh, I messed it up. 1.86 times 1.5. That gives me 2.79. So I get 2.79 times 10 to the what power?
9.
Yep, same rule we've been using, right? We have like bases here, they're both 10s. So all we got to do is add these powers. So 5 plus 4 is 9. So that would be the final answer on that one. All right, so that's kind of it for that first exponent rule. We got 2 more rules to do. So if you look at this example right here, it says 2 to the 3rd squared. Well, we know that when you square something, it means to multiply by itself, right? So that would actually be 2 to the third times 2 to the third. That would give us 2 to the what? Yeah. Yeah, we have like bases there, right? We have a base of 2 and a base of 2. So we would just add these powers. 3 plus 3 is 6. All right, same thing over here. So on this one, you got 6 squared cubed. Well, if something's cubed, it means it's multiplied times itself 3 times. So this would be 6 squared times 6 squared times 6 squared. Which would give you 6 to what power? Yeah. Yeah, you add the powers, right? If you have like bases, the powers, you add them, you get 2 plus 2 plus 2, that's 6. So that one's 6 to the 6th. So now, what you got to do with this is kind of skip that intermediate step, and what you want to say for the shortcut or the formula for how you do this is how do you get from here to here? What do you do with the exponents? You're looking at these exponents right here. What did you do with these?
Multiply.
Yeah, you multiply them, right? Let me zoom in a little bit so you guys can see. Yeah, you did 3 times 2. 3 times 2 is how you get the 6 right here. So you multiply them. That's what goes in the blank. So multiply them. And your book calls this, they call this exponent rule number 2 is power of a power. So what you have on these, like right here, is you have a power raised to a power. All right, so the rule on that would look something like this. You would have a to the m, that whole thing to the n power. So that would be a to the what? If we multiply them, what would I write? What's that? Yeah, m times n. So it'd be m times n. You guys good with that one? All right, so then we got to turn the page, right? So now we're going to apply that rule. So number 6 there, that would be 5 to what power then? Yep, you multiply. When it's a power raised to a power, you multiply. So that'd be 5 to the 2 times 4 power, which would be 5 to the 8th. And again, for our purposes, you can leave it like that. You don't have that memorized, what 5 to the 8th is. 5 to the 8th is a pretty big number. 5 to the 8th is, that's 390,625. All right, the next one, multiply the powers. What do you get? 4 to the what? Yeah, good. 3 times 0 is 0. What's any number to the 0 power?
1.
That's 1. Good. All right, number 8. Let's see, 8. So you're going to do this part first. You got a to the, yep. You multiply again. It's a power raised to a power, so you multiply those. So that's going to give you a to the 12th. And then that's going to be times a to the, yep, if you multiply those, it's a power raised to a power, so you multiply -2 times -3 is +6. Now you go back to the first rule. So you did a power of a power. Now you got to do, what do they call the first rule? I don't remember what they called it. Product of powers or something. It's the first rule. So what do we do with that now? What can we do with this? This is a to what?
18.
Yes. Yeah. Now we have like bases there, so we add the powers, right? So that's going to be a to the 12 plus 6 power. So we get a to the 18th. All right? So now we got one more rule to go. And then we're done. This one, they already wrote it out. They said if you got 6x to the 4th power, well, if it's to the 4th power, it means it's that thing times itself 4 times. So you got 6x times 6x times 6x times 6x. Well, that would mean you have right here, you have 6. Again, you can multiply in any order you want. Multiplication is commutative. So you have 6 times 6 times 6 times 6. That'd be 6 to what power?
4.
Good. And then you also have x times x times x times x. That'd be x to the
4.
4th. Good. So then, again, kind of ignoring that part in the middle, what's the shortcut that takes you from here to here? What do you have to do? Hold on. To get from there to there. I don't want to write over that. Hold on.
Multiply the power by both.
Say it again?
Multiply the power by both. Like,
Yeah, it's kind of hard to say. How would you describe that?
like distributing the power of both.
Yeah, it goes on, well, they're both factors, okay? When you have 6 times x, right here, if you got 6 times x, those are called factors. That's a product of 2 factors. So, and then you said distributed on it, but it's really not the distributed property. But basically, you just put the power on both of them, right? On both factors. So, I don't know how I'd say that. Let's see, we could say something like this, raise. Let me see if I can write a little bit neater. We're going to say raise each factor to the power. So basically, you put the power or the exponent on each factor in the product. So then that's exponent rule number 3. They call it power of a product because you're raising a product to a power. And that would look something like this. You would have a product, so like A times B, that whole thing to a power. So how would I write that then? Put the power on both of them. What would I write? A to the
A power.
A to the what power?
Is that N? N.
Yeah, A to the n power times. Yep, good one. B to the n power. So it's just A to the n power times B to the n power. So the power goes on both of them. And then we just got these last 3 examples and we're done. All right, so number 9. Number 9, that negative out in front, that stays out in front. So what that really is, it's really like a negative 1 times 2y to the 2nd power. Then you have your product there inside the parentheses. So you have to put the power on both of those factors. So this is going to look like negative 1 times 2 to the 2nd power, y to the 2nd power. Well, what's 2 to the 2nd power? We can do that. What's 2 squared, guys?
4.
That's 4. So that we can do. Like if it was 2 to the 8th power or something, you would just leave it as 2 to the 8th. Okay, but you know what 2 squared is. That's just 4. So we got negative 1 times 4. Well, that's a negative 4. And then we also have a y squared there. So that's it for that one. Now number 10, You notice that the negative is inside the parentheses? On number 9, the negative was out in front of the parentheses, right? So you just left that in front of your answer. So on number 10, the negative is inside the parentheses. So that means that whole thing is raised to the third power, okay? So it's a negative 2 that's raised to the third power. And the y is also raised to the third power. There's your multiplication right there and there. And again, notice that generally in this class, whenever I have a negative number to a power, I always put that negative number in parentheses. Now, what's negative 2 to the third? That's negative 2 times negative 2 times negative 2. No, don't add, multiply.
8.
Yep.
Negative.
Yeah, negative 2 times negative 2 would be 4 times negative 2 would be negative 8. So it's a negative 8 and then a y to the third. So that's your answer on that one. And we just got one more to go. Okay, so this last one, you've got a product of 3 factors here, and they're raised to a power, so then the power needs to go on each one of them. So you're going to have 3 to the second power, you're going to have x squared to the second power, and you're going to have y to the negative 3 or negative third power squared also. So you're squaring each of the 3 factors in that product. All right, so then what's 3 squared?
9.
That's 9. And then you got x squared squared.
X to the 4th.
Yes. When you have a power raised to a power that, like that, you multiply them, right? So that's going to give you a x to the 4th. And then same thing with the y there. What are you going to do with those powers? Multiply, not add, okay? Hey, look at if it was y to the negative 3 times y to the second, that's where you add the powers. But when you have a power raised to a power, like on this one, you multiply those. So that's going to give you a y to the what? Negative 6. Okay, now you got to go back to yesterday's lesson. So none of your, like you might get some negative powers as you're working through the problem, but your final answer cannot have a negative power in it. So no negative exponents in your final answer. So what do I like to do? That's not what I said yesterday, though. What did I say yesterday?
Move it.
Yes, move it. You got to move it. Which one you got to move? Which one? Rachel? Yeah, the y. You got to move the y. Where does it go? On the bottom. It goes in the denominator. And then what's the, well, let me write it out. So then, now what's the power on the 9? That's a 1, right? So if it's got a positive power, you leave it where it's at. So the 9 stays in the numerator, the x to the 4th stays in the numerator, but then the y goes in the denominator. What's the power on the y? Yes, positive 6. So when you move it to the denominator, you change the power from negative to positive. So then that's your final answer on that one. And that's all of it, isn't it, or no?
Yeah. So nice, but now we
Not yet. Not yet, but soon. So let me stop this recording.